Okay, so the section on making conjectures, I think I may film this all in one video and you can, watch it in pieces, obviously. Um, the sections are labeled. This whole module is going to be we're going to hit this a little more lightly than the rest. You'll probably be able to tell the reasoning for that as we go. So the first thing is good definitions. If in math, because we start with a premise, an axiom, and then try to prove things from there, we need to have really good definitions. We can't have kind of vague terms to explain what something is, because then we can't prove anything about it. So a good definition uses clearly understood terms. So they're either commonly understood so that anybody would be able to understand them, or they themselves were already defined ones. They need to be very precise. You can't say large, sort of, some, and they need to state what the term is, not what it isn't. So if you were trying to define big and you said big is the opposite of small, then that's not very clear. You don't know what small is, and opposite is a little vague itself. Okay, so we have these undefined terms like point, line, and plane, and we have to have an understanding of what those things are so that we can define other things in terms of them. So a point is a location. It doesn't have any measure in any direction. It's got no width, no height, no depth. It's just a single point with zero measure. So we'll call it a location in space. And we would notate it just with the letter. And if we were to draw it, we'd label it like this. But it really doesn't have any of that. It's not the size of that circle. It's a size you can't see. A line is a set of points that goes two directions forever. You've probably heard a line segment defined as the shortest distance between 2 points, and it is that, but then you have to keep going as though nothing interfered with you and you were in a vacuum and you just kept moving forever. When you draw it, you either draw it in terms of 2 points, or you just draw it and label it with a letter, which is usually italicized. So either it's an italicized letter, or we put this little symbol over it indicating line. The arrows mean in both directions. If I had one arrow, it would be a ray. It would start at A and only go in one direction. If I had dots on both, then it's a segment, but we don't draw them then. We just draw a little line. A plane is a flat surface that extends in all directions without ends. So it's 2 dimensions only. It doesn't go at all in the third direction. And if you were to draw it, you'd either use 3 points to define it, because 3 non-collinear points determine a plane uniquely. And then you would put, in this case, a W. And then you can say plane W or plane ABC. Like before this one, you could say a line from AB. This is a plane from ABC. Collinear points means points that are on the same line. Coplanar points are points on the same plane. And coplanar lines are lines that all lie in the same plane. Okay, so this one, we want to look at this example. We're trying to come up with kind of a definition, okay? So we're doing it by the process of look at things that are a rectangle, look at things which are not rectangles, and decide what the first group has in common that the second group doesn't. So the first group, the first thing you might notice that they all have in common is that they all have 4 sides. But there's one over here that also has 4 sides. So what's the difference between these? Well, there are 2 actually. So then you might look at this one and say, oh, well, these 2 sides should have been the same length, because that's what's happening over here, is that opposite sides are the same length. But that's true on this one too. So then the thing that makes these 3 different from that one is that these are all right angles, and this one isn't. So it looks like, knowing that there are 4 sides that make right angles, which forces, by the way, for the opposite sides to have the same length, is a good enough definition for a rectangle, as far as we can tell, having been given these examples. So that means that D is the correct answer over here, and a rectangle is a quadrilateral lateral always refers to sides, so quadra means 4 sides, so it's a quadrilateral with all right angles. And that's a rectangle. So here's something a bit more arbitrary, something you don't know. So group 1, those guys are all zoids, and the figures in group 2 are not. And we need to figure out which one in this last group is a zoid. Okay, so color is obviously not something we need to consider. We can look at the number of eyes. So really all we have to look at is head shape, tail shape, number of eyes. They all have one mouth, and color. And color, of course, not an issue because they're all different colors. They all have 2 eyes, or 2 dots, whatever those are. They have 2 of them. So that's one thing. So we would look over here, and that's not enough, right? Because this guy here, this guy has 2 eyes, or dots, also. So he's not a zoid. So what's the difference between this guy and those guys? He's yellow. That seems fine. But his tail has 3 little, whatever they are, points, okay? So it looks like the only thing we can know for sure is that a zoid has 2 dots and 2 points on his tail. So if we look over here, this one has 2 dots, this one has 2 dots, that one doesn't, that one doesn't. This guy only has 1 point on his tail, and this one has 2. So this is the zoid. So a zoid is a, whatever those things are, a creature with 2 dots and 2 points on the tail. And there's more to it than that, but whatever there is more to it, they all had in common. So we don't really know how to quite describe that. Okay, so that's the end of that portion, the definitions portion. Now we want to talk about midpoints and bisectors, which are related objects. Okay, so A, B, and C are collinear. B is between A and C, so it looks like this. So they're all on the same line, and B is between them on that line. Okay, so the result of that is that the measure of the line segment AB, which we notate like this, plus the measure of the segment BC, which is just notated like this. So if we don't write anything on it, then it's the length. That equals the entire thing. So however far I have to travel to get to there, added to however far I have to travel to get to there, I had to go through B to get to C because they're on the same line. So that equals the whole thing. Okay, so in this case, we have that 20, the measure of ST, plus N, the measure of TV, equals the measure of SV, which is given to be 2N minus 1. So we subtract N from both sides, and we add 1 to solve for N. On this one, we have that A, the measure of XY, plus A plus 6, the measure of YZ, equals 36, the measure of the whole thing. So that means that 2A plus 6 is 36. Subtracting 6, 2A is 30. And then dividing by 2, a is 15. Okay, on this one, we have, you know what, I'm going to clear this so I can write up at the top because the pen gets more jaggedy toward the bottom. There's not much room anyway. Okay, so now I'm going to write 16 up here where I had just written 14. Also, I'm a little tired of red, so... Okay, so on 16, we have that x plus 3x minus 12, so this plus this, equals 3x plus 1.5. The 3 x's can be subtracted off, so you can gather this up and say this is 4x minus 12. Then subtract 3x and have your x back. Or I can just say, basically like I have a scale that's the equal sign, and I've got 3 of something on one side and 3 on the other, and I toss them both. Then x minus 12 equals 1.5, and then I just add 12. Okay, now this one seems a little bit more confusing. So AD is given to be, 27. I should have written that on the other side down here. That's 27. This is 2x. This is x. We have 3 pieces this time. So one thing I can know is this little one here is 2x minus 3, because this one plus 3 gives 2x. So this is the 2x, take away the 3, chopping off 3. So 2x minus 3. So that means 2x minus 3 plus x, so now I'm doing this part and this part, equals 27, because that's what the whole AD is. So 3x minus 3 is 27, 3x is 30, so x is 10. Okay, so we want to look here, and we're given a group. This is similar to what we did with the zoids and the rectangles. These are all bisectors. These are not. So the first thing is you can see that bisectors can be rays, line segments, or lines. But a segment bisector is anything that it cuts it, but so do those, right? So these all cut, these all cut. So that's not enough. The first thing you might notice over here is these numbers, 3, 3, 1.5, 1.5. So those are the same. And then these little double slashes actually mean that those are the same. And the single slashes mean that those are the same. Anytime you put a little mark on it that's identical in both places, you're saying they're the same. Over here, you've got 3, 5, not the same. 1 mark, 2 marks, so not the same. 21, 20, not the same. Bisector seems like it should cut things in half, and in fact, I already kind of assumed this definition in the previous module. So it bisects, it cuts it in half. So a segment bisector is a line, ray, or segment which cuts a segment into 2 equal pieces. So the word equal is what differentiates this group and this group. Okay, so now we want to complete these statements. We can see that these bisect each other because of the 2 dashes, and the 1, 1. So that means they're the same. I think they should make a purple pen. Anyway, so MR is given to be 24. So that's this. So the question is, what is HR? Well, it's 24. Because they are marked that they are the same. So if this one's 24, this one's 24. This one says TR is 16. So this here is 16. And it asks, what is AT? AT goes all the way across. So if this is 16, then this is 16, which means the whole thing is 32. If MH is 58, so that makes this not 24 anymore, so I'll scribble it. So this is all 58. The question is, what is MR? It's half of 58, because this plus this equals 58, and these two are the same. So you have that basically 2 times MR equals 58 by substitution, because RH is MR. So then MR equals 29. R is the midpoint of both MH and AT, because those two match, so it's the midpoint of AT, and these two match, so it's the midpoint of MH, and you could have written HM and TA. It doesn't matter. Okay, so we're given AB, and the first question is, how many midpoints does it have? So if I start from A and go halfway to B, I get to a point somewhere about here, and no matter if I start from A or B, if I go halfway across, I get to the same point. It only has one midpoint. It can have bisectors that are rays in either of these directions, that are aligned, or that are segments, and the segments can be any length. So it really can have as many bisectors as you want because of all the different rays and segments that you could draw. So infinitely. Given JB is the segment bisector of AD, oh, also, failed to mention, it could have gone this way. It doesn't have to be perpendicular. So even if you restrict yourself to lines, there are infinitely many. You can turn this any direction you want as long as you pass through there. Given JB is the segment bisector segment bisector of AD, so this line is splitting these two. If AD is 24, so this whole length is 24, and this is the middle of it, remember, AZ is 2x plus 4. Well, if this whole thing's 24 and each of these is half, then this is 12. So 12 is 2x plus 4, which means that 8 is 2x, subtracting 4 on both sides, so x is 4. Yeah, I thought that wouldn't show up down there. Okay, now we want to use this one figure for all 4 of these. What is the midpoint of AB? So AB is from 0 to 8, so the whole length is 8. So we need something that's 4 away from the ends, so Q. So again, that's just because this is 4 and this is 8. What is the coordinate of the midpoint of W? A. It's not on here, you can see that. But this is 8, so we need something that's 4. And if I move 4 away from 0 in this direction, I get to -4. The coordinate of the midpoint of AR is -5. So here's -5. And it's the midpoint of AR. which means r is over here. The coordinate of r, so I've gone -5. I need to go 5 more to the left, so that's subtract 5. So start at -5, go 5 more to the left, and you get -10. The coordinate of the midpoint of ST is 7, so S is at 2, so you go here to get to 7, and you keep going over there, and this will be T. So from S to 7, we moved 5. 7 minus 2 is 5. So we went 5 to the right. So we're starting at 7 and we're going 5 more to the right, which means we add 5 and we get 12. So this one, you can see we have another one of these where they're bisecting each other, and we're given first TM is 3x plus 5. MQ is x plus 17. And we want to find x. Because of that single hash mark there, these two are equal. So we can just say, well, 3x plus 5 equals x plus 17. Subtract x from both sides. Subtract 5 from both sides. And dividing by 2, x is 6. I'm going to go back and erase this now so that I can use this space for the next problem. Of course, you can always pause if you need to write stuff down. And I'll even change pen color so you have less trouble seeing it. Okay, so this one says AM is 5y minus 1, and AB is 38, and we want to find y. So what we know about this is that AM plus MB is 38. But AM and MB are the same, so that means AM plus AM is 38. So 2 times AM is 38. AM is 19. So 5y minus 1, which is AM, is 19. 5y is 20, adding 1 to both sides. Y is 4. Okay, so this brings us to patterns and inductive reasoning. And remember, inductive reasoning isn't always perfect, but sometimes it can give us a good guess. And those guesses are called conjectures. Okay, so we want to look, you've probably seen stuff like this. I wouldn't be surprised if this kind of stuff shows up on that test you take. Maybe it's called a COGET, something like that. These are your kind of typical IQ test type stuff. So we first have March, May, July. When you see months, you normally think that maybe you're skipping some, or maybe it has to do with the spelling. So in this case, let's first think if we go March, April, May, June, July, August, September. So that seems to have worked. So our conjecture would be September. And if it had been March, June, we would have gone March, April, May, June, July, August. And if September was the next one, then we would have gone October, November, December. So we're just seeing how many it skips in between. On this number 2, 1/3, 2/4, 3/5, if you think about them as fractions, it's not super clear. 2/4, of course, is 1/2. So then you'd expect 1/3, 1/2, either 2/3 or 1/1 or something. So let's look at the top and the bottom separately. That's fairly common in patterns, and That's another thing we'll talk about more in 11th grade, is sequences. But in this case, 1, 2, 3, 3, 4, 5. So our assumption would be that the top would go to 4 and the bottom would go to 6. And we're obviously not concerned about reducing, or this would have not been there to start with. And then this one is maybe takes more thought. So you notice there's 2 lines in one circle, 3 lines, 2 circles, 4 lines, 3 circles. So probably the next thing will be 5 lines and 4 circles, but this is also vertical, horizontal, vertical. So the next one will probably be horizontal. So 1, 2, 3, 4, 5, circle, 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 circle. Number 4, we've got 8 a.m., 11 a.m., 2 p.m. This is something you're fairly familiar with, so it probably occurs to you that's 3 hours, 3 hours. So our best guess would be 5 p.m. 75, 64, 53. Your first thought would probably be subtraction or addition, right? So since we're going down, probably subtraction. Sometimes it'll be squares, sometimes it'll be multiples, but 75 and 64 are not super related. This one's a square, this one's not, this one's prime. So you can't really think of factors very well. So 75 to 64 is subtracting 11. 64 to 53 is subtracting 11, so probably we need to subtract 11. This one could have also come more straightforwardly by 765, 543, but then a couple of times later you'd have to subtract 11 because you get to 0. So what I mean there is 31, 20, the next time you go to 9, so it doesn't go down from 2 to 1 and 0 to something. Okay, now on this last one, those are missing pieces. Sorry about that. Okay, so this was originally a triangle and a square and a pentagon. So all of them are regular polygons. They all have equal length sides and equal angles. So equilateral triangle, 2 square, 2 regular pentagon. The next one should be a regular hexagon. Okay, on this one we're going to write down what our conjecture is first, and then fill in the next terms of the pattern. So from 2 to 4 to 16, when you see 2, 4, you might think 6, 8, or you might think 8. But in this case, 2 goes to 4 and then 4 goes to 16. So the relationship between 2 and 4 can be adding 2, it can be multiplying by 2, it can be squaring. And the one that gets us then from 4 to 16 is the squaring one. So previous term squared would be our conjecture about what the pattern is. And at any rate, it fits so far. So if that was the case, then you'd have 256 for the next term, and then 256 squared is 65,536. On this one, you still see the 248, so this is similar. You could say, okay, well that's the multiply by 2 relationship, but because it's in the bottom and the top staying the same, you're actually multiplying by 1/2. So you're multiplying by 1 on the top to keep it the same and 2 on the bottom. So multiplying by 1/2. So 1/8 times 1/2 is 1/16. 1/16 times 1/2 is 1/32. This one, 3, 6, 9, 12, you could get a handle on. You could just say, I'm adding 3 each time. But that negative, the negative, positive, makes it an alternating sequence. And generally speaking, we have to multiply by -1 to get that. This one has this weird kind of combination of adding 3 but multiplying by -1. To write that down, you could write it in a kind of crazy way to get from one to the other. You could say, well, I'm going to multiply by -1, and I'm going to take the absolute value of this and add 3, but it's kind of crazy. So the easiest thing to do is define the term explicitly. So instead of saying what you do with the previous term, we can say the nth term is -1 to the n. So on the first term it's negative, on the second term it's positive, negative, positive, times 3 times n. So 3, 6, 9, 12. This is harder to write down, but you could have easily, without writing this down, just written the next terms, right? So in this case, the next terms are easy to write down, the formula is hard. In these, the process, the conjecture was easy to write down, and these were harder to solve. So, okay, now we have a laboratory culture with bacteria. And I think you've already had algebra 2, so you actually know generally how bacteria works. But we want to look at it from a conjecture based on a pattern type of thing. So a laboratory culture contains 150 bacteria. 20 minutes later it has 300. So your very first thought there is it doubled in 20 minutes. After an hour it has 1,200 bacteria. So let's suppose that what we thought was right. So our first conjecture is it doubles every 20 minutes. Okay, so if it did, then after 40 minutes, it would have had 600. Because from the 20 minutes to the 40 minutes would have been another 20 minutes, and it would have doubled again from 300. And then it would have doubled again 20 minutes later, which would have been an hour. And that's what happened. So our conjecture is it doubles every 20 minutes. Okay, this is actually our last slide on this. Which of the following conjectures is false? If x is odd, then x plus 1 is even. Numbers go even, odd, even, odd, even, odd, even, odd. And adding 1 always takes you to the next one. So if x is odd, then x plus 1 is even. So that one is not false. This one's true. The sum of two odd numbers is even. So an odd number looks like 2 times something plus 1, because it's always 1 added to an even number. So if I take 2 of those, then I have 2x plus 2y plus 2, and that's even plus even plus even is even. So this one is also true. The difference of two even numbers is positive. So an even number looks like 2x. So 2x minus 2y, is there any reason for this to be 0? So as an example, 6 is even, minus 8 is negative 2 is negative. So if this would have said even, then it would have been true. But positive is false, so this conjecture is false. If x is positive, negative x is negative. That's true, since it's the thing that you have to add to x to get back to 0. So if on the number line 0 is here, and this is x, you have to go left to get to 0, so you have to add a negative. Okay, so that's all we have on this module, and I will work on getting an assessment up, hopefully today.